also talk about the assignment that you are going to do today, and yeah, that will be done.
Excuse me, sir.
Yeah. Yes.
Sir, when we can ask some of our doubts related to the previous one, will it be at the end of this session or in the beginning?
Okay, no problem. If it is related to tutorials that we have seen throughout these 3 days, you can frankly freely discuss today after the session. If we will, I think I'm sure we'll have plenty of time, so we can have discussion on your doubts, and if there will be possible solutions, we'll see instantly. Otherwise, we'll make note of it and share the solutions possibly later. Yeah, no problem. We'll have time for that.
Okay, sir. Thank
So
you, sir.
I'm thinking my screen is visible. If not, please let me know. So we'll start with a small presentation and then we'll go to demo part to see how the classification is implemented on simple text data set. So let's quickly start without wasting time. Everyone can see the slide? Yeah?
Yes, sir.
Okay. Okay, so first tutorial is on classification, how we can perform, use various approaches to do the classification task. So the topics are like this. First, we'll see a simple probabilistic method of naive Bayes, how it will be useful for the text classification. Then see logistic regression, which is a kind of nonlinear method to do the same kind of regression as well as classification. Then we will try to understand how the decision tree is implemented for the same task and how it is useful. Then random forest method, which is just an extension of decision tree. And then we'll try to also see and understand how the CI kit, which is also known as sklearn library of useful in Python to implement all these functions in a very easy way, in very few lines. Okay, so let's move ahead. And yeah, naive I'm sure most of you already has studied in the probability part of the mathematics. So let's quickly revise. So naive is based on this conditional formula where it says that the probability of hypothesis on a given evidence is estimated by this equation. Uh, okay, so for the terminology, you can consider hypothesis as a class because ultimately we are going to do a kind of classification problem. The number of class could be multiple. So think it as a multi classification problem, multi-class classification problem. So hypothesis is nothing but the class that we want to find out for the given evidence. So I think evidence as an input. Okay. So one input is given, and we want to find out the probability of each class. Okay, by this. So this part explains about that. So for suppose there are n classes, so this will generate n probability for each class for the given input e, and for whatever class the probability is higher, we'll say that okay, so this evidence, this particular input belong to that class. So how this is estimated, look at the right side of this equation, right part of this equation. So it uses some likelihood prior probability of the input. Okay, so the likelihood is nothing but how much the particular input is belong to that particular class, okay, for which we want to find out this probability. So this will give us the estimate of likelihood. Okay, and this comes from the data set that we have already. There will be n samples. From that we'll estimate these probabilities. This is the probability of hypothesis, means among all data in the entire data, what is the probability, how many samples belong to this particular class. Okay, so this is nothing but the distribution of data and into the corpus, and based on that these probabilities are estimated, and that will be used to find out the probability of a class for given input e. So we'll don't worry, we'll also see through the demo how it will be done. uh, yeah, so this slide, it is explained by an example. Okay, so the example taken is classify a given email whether it is a spam or not. Okay, so let's clarify the example. So the example, suppose email is consist of certain words. Okay, office, reach, money. So there are 4 words suppose in the email, and we want to find out whether it is a spam or not. Okay, so in order to find out whether it is spam or not, so this is simple binary classification problem. We also have to kind of first find out the probability from the given data. We'll already have a bunch of data to estimate these probabilities, and these probabilities will help us find out the likelihood and the classification probability to know whether this new email is a spam or not. So we already estimate, suppose, the probability for this spam. So there are 2 classes. One is spam, ham. Okay, ham is suppose stand for non, it's not spam. Okay, so for each word, we will estimate the probability belong to the particular class. So these probabilities are nothing but the likelihood that we discussed in the previous slides. This one, okay. And yeah, that's how it is done. These probabilities are estimated from the given data, and what it says, the friend word, which occurred 86 times, okay, uh, total 87 times, and which belong to this ham class. Okay, so based on it, the probability, suppose, is found out from the given data is 0.32 something. Okay, rich, for the rich, the probability is 0.01. Okay, how much rich belong to this class of data. Money belong to ham class these many times. So the probability here is 0.03. So this is how it is already, the probabilities are already estimated for both the class, for all possible words. And we'll use these probabilities as a likelihood for estimating class probability for any given new email as input. Okay, so this is suppose, so probability are already estimated from the data, and this new email comes, and now our job is to find out whether this email is a spam or not. And just by using the previous probabilistic formula, we can use it to find out. And one more thing I missed to tell you, that the denominator part will be a kind of constant for every example. So this is generally dropped off. Only the part of this formula is used to find out the actual probability of the class. So to estimate the probability of this email belong to ham class is estimated like this. Probability of this new email belong to spam class estimated like this. Okay, so let's go more deeper into it. So first of all, there are 2 terms that we have seen. The one is the prior probability, one is the likelihood. So or they will be multiplied. So first, let's take the prior probability, like how many data belong to ham class. So it is already pre-computed, it is 0.72. And how many data which belong to spam class is 0.28. Okay, so that's how the prior probabilities are estimated based on the number of data, number of samples belong to all both the classes. And now the likelihood of each term which is in the new email. So in the new email there are 4 terms: office, reach, and money. So for the office, uh, we need to find out the probability how much it belongs to the ham class. Okay, and we will look at this likelihood table. So office belong to ham class, the probability will get is 0.28. Okay, so that's why that number comes here. Similarly, we'll find out the probability for rich, and because it occurred two times, so we need to use the same probability two times. So for rich, the value is 0.01. So yeah, that's why 2 times 0.01. For the money, the probability is 0.03, 7 something, so rounded off 0.04. And ultimately, all these values, the prior and the likelihoods, are multiplied, and that will give you the probability on for this new email belong to the ham class. Okay. Similarly, in the same way, the probability of this email belong to spam class estimated. Just you will use the likelihood probabilities from this table instead of this table. Okay, because here we are estimating the class probability for a spam. Okay, so now finding out those probability values, multiplying them, you will get the probability of this new email belong to spam class. Now your job is very simple. You just see which value is higher. Okay, for if there are, because here we only have two class, so it is very easy to check. So between these two values, this one is higher. Probability of this new email belong to spam is higher. That's why I'll say that, okay, yeah, this email is actually spam. The problem was simple, but problem become complex when you have multi-class classification problem, because you have to estimate that many likelihood. Okay, if there are 5 classes, you will first estimate the 5 likelihood tables, and also for the new given input, you will estimate the 5 class probability in the same way that we did for the 2 classes. So that was the example. I hope it gave you some intuition how these probabilities are estimated and used to find out use these probabilities to do the classification task. So here no parameters are learned, only the probabilities are find out from the given data and use for performing the classification task as we have seen just now. Okay, going forward, next method is the logistic regression, and it is parameter based method because it learns the parameter and use that parameter to find out the probability of a given input uh, uh, into between 0 to 1. Okay, and if the probability you are getting closer to 0, it means the input belongs to this particular class. Okay, so and if the probability you are getting close to 1, that shows that the input belong to that particular class. So this method is useful for binary classification. Okay, and for multi-class classification, you may have to train multiple logistic regression, but that will be a complex scenario. So let's stick to a binary classification problem where we just have to use the logistic function to estimate these probabilities. And this is you must be curious why this S-shaped curve we are achieving. So this is actually the nature of logistic function. It uses a sigmoid function. I will show you the formula, don't worry. So that sigmoid function, when you give, so this is x and this is y. When we give any x input to the logistic function, uh, the curve you will get, the value that will be predicted by this will always be like this S-shaped curve. Okay. So this gives us the intuition that probability will always be between 0 to 1. If the probability is above 0.5, we'll say that it belongs to one class. If probability is below 0.5, we say that it belongs to the 0 class. And because this curve is non-linear, we also say that it is a non-linear regression function, and we can use it for regression, or also we can use it for classification. So if we want to understand what is the formula that actually being used to estimate this, the logistic probability is estimated through this sequence. where first the log of the probability divided by 1 minus p. Odds is suppose an input, a textual unit for which we want to find out the logistic probability. And so this is not the word is given as input, because machine learning only process the number. So we have to convert the given piece of text in the form of vectors. That's why the embedding concept came into the picture. That we use that embedding, gave to this logistic function, and it has already parameters, the weights, and those weights are put into this formula and find out the probability. So the final logistic function that you may observe is like this, where e to the power log of input divided by 1 plus e to the power of log of input. Okay, and this will give you the probability, and this function will always be a S set function. Okay, the output of this function would be S set, and based on it, and one more thing, the probability will always be between 0 to 1, and that it help us deciding to which class the given input belongs to. We'll see with the some examples during the demo how it goes. And next useful method is the decision tree. This is also a statistical method. Means all these, although it looks graphical, but all these division of the nodes, how the nodes are estimated, which particular location, what would be the division criteria, it all decided statistically based on the given input. We'll see in with the code how it will be done. But the main intention is that for a given, when the decision tree is formed based on the given data, a new input is came into the picture, and we want to assign it to the particular class. So this picture actually is again a binary classification problem, which shows that if you do smoking in your age and your weight, if these values are given based on it, it tells you that what are the chances of heart attack, low or high risk, based on the given input to these features. So there are supposed three features. So in forming the decision tree, the internal nodes will always be those features, those input values. Okay, the age of the person, the weight of the person, whether he's a smoker or not, and so those features will always be internal nodes, and based on its value, uh, the division will happen. Okay, means you will move to a particular sub node, and the leaf node will always represent a class. Okay, whether it is low risk class, high risk class, again. So leaf node, when you start from the root node and reach to a leaf node, your traversing to this decision tree is done, and as soon as you reach the leaf node, you will get the class label, and you'll say that okay, based on the given input, you have very high risk or low risk of getting heart attack based on the given input. So we'll see with example during the demo. So this is the pseudocode to implement the decision tree. So on the left hand side, the pseudocode that you observe is actually the pseudocode for training a decision tree, which actually use the given data sample. Okay, so there will be n samples and data points, and each data will have values of certain features. Okay, so those features are nothing but these the age, weights, and smoke, and all. In the textual unit, those there will be all those embedding dimensions. Okay, based on it will decide how. But this example is mostly useful for categorical problems where the features are uh, discrete and more understandable to human. So the steps are like this. It, so this is a recursive method. Okay, in the recursive method, it will check whether the stopping criteria reached or not. First of all, stopping criteria, when you reach to the leaf node. If you reach to the leaf node, you will just assign the label based on the data that we have, and return as an stopping criteria. If the current node is not leaf, it will create a node and assign to the feature name to that. And then based on the possible values for that feature, it will use those possible feature values to find out the division criteria. Okay. And that division, and once again, before finding out the division criteria, it has to select the feature on which the division happened. So that feature selection is happened by, there are various approaches. uh, you can look at some data mining books, and there will you will find there are certain for methods to find out the which features to select, so that we can better divide the samples into two set of uh, clusters. And that will give you the best feature to select, and that will be used for dividing and deciding to which direction move based on the given value. And there, because there will be some v possible values for the give that feature which we have selected, and based on it, division will happen. And for each value, again it will recursively call the same function to further find out the feature in the traversing of the decision tree. And is this way the whole decision tree will be formed based on the given data. And on the during inference time, we'll use the decision tree to do the prediction and find out the actual class for the given testing data. So it looks complex, but actually it is very easy, and it relies on certain methods like the finding out the best feature. So there are some criteria which has to be understood for uh, generating the decision tree for the given problem. You must have also heard about random forest many times. It is very useful and generally gives the best accuracy among all the methods, because first of all, it is based on decision tree, and not one decision tree. It generates n decision tree. Uh, that depends on how many trees the user wants. And to train each tree, the process would be same. The algorithm, the method that we just discussed in the last slide, will be used for generating those trees. And but how each and every tree would be different from each other, it is actually decided by the data used for training those trees. Okay. So the random forest method, what it does, from the entire corpus of samples, it randomly picks a subset of data. Okay. And after picking some subset of data, it decide it trains the tree, like tree 1, tree 2, and tree n. And after, when the training is done for all those n trees, during the inference, they will be used for prediction. Okay, suppose one input is given, that input will be given to tree 1. It will generate the label with probability. And the same input will again given to the tree 2. It will again generate some class label with probability. And again, okay, so likewise the same input will I'm talking about the testing phase. Okay, the same input would be given to all entries which are already trained earlier, and we'll get n number of classes. And whatever class has higher count, that will become the major class for that given input. So this is nothing but the majority voting of classification, averaging. Okay, so whichever class got the highest count will be the final class to do that particular input. And due to its ensemble nature, it does not have overfitting problem, which the simple single one decision tree might have, because due to the imbalance in the data, or the less amount of features uh, there in the data, so there may be some overfitting problem, but this ensemble method uh, avoids that situation and handles the overfitting problem. Okay, so these were some of the methods that are really useful for the classification task. And if we want to look at them and see how they can be implemented, there is a very beautiful library in Python which is available, SCI Kit Learn. We also call it SK Learn, which actually has given the implemented part of all those algorithms, and we can simply use them, give our data, and find out the output in no time. So this is a toolkit very useful for data science machine learning. It is built on NumPy and SciPy, and also has matplotlib access, so we can directly generate the graphs and histograms for the given data and input. So we can also do the visualization part. So that make it more useful, uh, and which because it is open source, so it's has really very useful utility in various data understanding part, data science and machine learning. So moving ahead, the task, uh, although we are going to simply see the classification task, but all these methods are really useful for the regression problem as well. So let's try to understand with this diagram. The regression is nothing but to predict a continuous number. Like suppose you want to train a model to predict the temperature for tomorrow or the any day. So the temperature could be a range of number, okay, like suppose 30 to 40 temperature. Uh, so based on some certain input like today's temperature and was the possible whether the day was sunny or day or cloudy day. So based on it, based on the certain features, it will try to predict the number in a particular range. So that's why it is a regression problem. So predicting attribute value associated with an object. The classification problem is always a categorical problem, which classifies the given input into certain number of classes, the whether we want to know tomorrow it will be hot or cold, something like that, based on the in features given as input. So that was the basic difference between regression and classification. There are some other function which is already defined in the sklearn library, like label encoder. Generally the data that we have, the labels are is not numbers, they are a string. Okay, suppose the labels that we assign to each student is tall, medium and short, and we know that our computer only handles the numeric values. Okay, so we need to find out some way so that these labels which are in the string format can be converted to the numbers, and which will be processed by the system to train model and do the processing. So the label encoder is a very useful feature, we can say the option which is provided by sklearn library. We can use it and give our data, which will automatically form this conversion, okay, from string to number. And the next thing comes, if you got the numbers of the features, all the features would be numeric, and you found out that some numbers are very big. For example, from this data you can observe the age. Okay, the numbers are really small, but the salaries are really big. So that kind of big fluctuation affects the machine learning method, and that's why we need to normalize the values into certain range, so that the machine learning models can avoid those big fluctuations and do the training in a more effective way. So there are certain methods like uh, uh, standard method which actually uses the mean and standard deviation to normalize the given input. So what it just do the subtraction, like x is given which we want to normalize. So subtract the mean and divide with the standard deviation, and you will get a unit variance, or we can say unit normalized value for the given x, and that will be used for, during the training. Another method is which is also people use is min max normalization, in which the minimum of any feature x is subtracted from the x, and the difference between max and min value for x is used in the denominator. So this formula actually reduce all any feature value between min and max. So by this formula, min will become 0 and max will become 1. Similar, the same way you can see here with this min max normalization method. So because 27 and 47K was the minimum for age feature and salary feature. So that's why it becomes 0. And yeah, and for this 48 class, it become 1 and 1. So yeah, that was the also very useful and very important point. Another thing is, if you have given a very big corpus, the entire corpus have to be split into certain parts, training, validation, and test. And training validation are useful and generally used for during the training part. And when the model is trained, we also try to evaluate on the unseen test data to find out whether the model has generalization of that one, generalization on the given unseen data. So that is the main objective of this one. And now I'll go to implementation. uh, just take a 2 minutes break, and then we'll move to the demonstration and start from there. Just two. Okay. So yeah, before we'll move to the demo part and see how those classification method can be used to perform on the textual data. Before moving that, if anyone has doubt, let's quickly try to resolve that. Just let me know. Otherwise, we'll move and quickly wrap up with the demo and see how it will be. They will be used for the given data. Vivek, uh, do you have some queries?
Sir, when you were talking about label encoder, isn't
Yeah.
it simply working like a key value processor? pair. So was it something I'm missing?
Yeah, yeah, it's a very simple thing. So that people also generally prefer to do manually, just create a dictionary, which will transform the given string label to the numerical labels, and also do the reverse part. Means if the after prediction when you get the numerical classes in numbers, so you will have reverse dictionary which will transform those numbers to the string class, so that you can show to the user that okay, for this particular input the class is like that. So that part can also be done by simply generating two dictionaries. But training a labeler is a more simpler way. It's just one line statement. You just pass the list of labels, and rest will take care of that labeler function, labeler class actually, and which is provided by SQL. So it is more compatible with the training model functions and testing functions. So people generally prefer that. But yeah, your doubt is correct. That can also be done manually by ourselves.
Okay, sir.
Yeah. Okay, so let's move ahead, and I will be sharing the Jupyter notebook that we have created, and hopefully my screen is still there and visible to everyone. If not, please let me know. And so we have selected a intent classification problem where we will have a set of utterances, and each utterance is actually assigned with a class label. Okay, and our job is to train some machine learning models to do that intent classification task. So before implementing those methods and see how they will be used to implement on the given data, let's quickly see with the diagram and understand how they are implemented and what is their objective and how they do the prediction and all. So linear regression and logistic, we know that the difference both are regression method, and logistic one can also be used for binary class classification. uh, so the difference is the linear regression generally plots a linear line for the given set of samples, and it predicts a numeric output. Okay, suppose this is on x direction, we give input, and the y direction is the prediction. Based on the given input, it use the weights, trained weights, and do the prediction. And so it is useful for regression problem, and this method is linear, so it means there is no any non-linear function utilized, and it cannot capture if the data is non-linearly separable. What is non-linear separable data, we'll see in the next diagram. Logistic one have the capability to do the binary class classification, because it's a logistic function. The sigmoid function has that capability. It takes the input and do the prediction and find out if the probability that we are getting for the input is below zero point 0.5. It is we will say that the input belongs to zero class. Okay, so we can understand this one, the red one. And if the probability we are getting is 1, above zero point 0.5, we'll say the given data belong to one class. And that probability is estimated by the logistic function, the same sigmoid function. And yeah, I was talking when what will happen if the data is not linearly separable. So here we'll see that there are, although the data are of two classes, the red one and green one, but there is no clear linear boundary which can do the division, which can divide the data into two parts. So although they are non-linearly separable, non-linearly means the circular, if we able to find out such parameter which can form this circle, we can easily divide the data into two classes. But these the linear methods, even the logistic also, because ultimately it also draws a linear line between a set of data, cannot do that. So here the support vector machine or any nonlinear method which is useful is used. So what it does, it because it relies on the kernel function. Okay, the different kernel function, RBF and Gaussian kernel function. So what those kernel functions do, they transform the given input into some higher dimensional space. Okay, and in the higher dimensional space, they are now become linearly separable. Okay, linearly separable, we can simply draw a linear plane. Now it will be called hyperplane because uh, the plane is now in the imaginary coordinate system. So that's the beauty of the support vector machine, because it project the data from one particular dimension space to another dimension space, which is generally higher, means the dimension would be higher if for any input the dimension is n here. So there here you will find out the number of dimension values higher than n. So that is what this SVM performs, and then ultimately trains a projection layer, sorry, an hyperplane, and which differentiates the two set of data that we want to achieve. The decision tree, uh, we already seen the basic of it. Uh, this is how it is trained for the given input. So here the data is actually some set of values, like and the objective is to find out whether to go to play golf or not. Okay, play golf, yes or no, based on these possible values, like outlook, whether the day is rainy or overcast or sunny. Overcast means whether the area where we want to play it is already covered and there's no problem of whether it is rain or not. We can simply play inside uh, that courtroom, which because it is already covered. And temperature, if it is hot, generally people avoid to go. If it is mild or cold, uh, people will prefer to go. Humidity also plays, and windy also plays role. So based on these features, it will generate a decision tree. And as we have already seen, on the leaf node will tell us whether to go for playing golf or not. Okay, and all the internal nodes are nothing but those the features. Okay, so the decision tree are formed like that. On the root node it is outlook, and if you are curious how those are selected, I told you in the pseudocode there is a selection method which, based on the given data, find out which feature is the best way to divide the data into two parts, and that's how it follows that criteria and choose the feature and generate the decision tree. Random forest, we also see the same uh, description here. It trains n number of trees, decision trees, and use the output of those decision tree by majority voting. Means just count the find out for which class the count is higher. Okay, if for any class maximum number of trees return the same class value, we'll say that okay, the for the given input, that is the final class. Okay, yeah. So we'll move to the same problem that we just told you, the intent classification problem. So we have to load some of the libraries like NumPy, Panda, Matplotlib, label encoder that I told you about, to for transforming the textual label to numerical label, and again numerical label to textual label. So yeah, it is done, and the data we have saved in a TSV file, means tabs separated data file. And so there is a training data and testing data. Let's load them. Yeah, they're loaded. And now if you want to see what is there, want to get a glimpse of data, what is there in the training file and the testing file, let's quickly call the head function on the data training data frame. So you will get there are various columns, but we have to look for only two columns. Only two columns are useful for us. The utterance, okay, utterance is actually the textual unit, and intent is the class that we want to classify. Okay, if utterance is hello, so the class label is opening greeting. If the utterance is suppose I would like to purchase the internet connection, okay, so for this the intent is start service intent. Okay, so this is one label. If the utterance is Washington, some pin code 10 GB, okay, 10 GB plan, so these are some other utterances for which the class is content only, they represent some content. So this is how there are various data samples, okay, and number of, we'll see total how many samples are there. Similarly, the testing data also have the same formatting. It also consists of utterances and labels, intent labels. And our job is to train some machine learning models and see how they perform on the classification task. Uh, we also want to do some filtering uh, as a cleaning part, because there are some samples which are very less represented, and using those data may not be significant in training the classifier. So we'll do this cleaning. Okay, so first find out the total data which are there, and the associated cloud counts. So the data with this class, this intent class, is only has count only 6. Okay, so the utterance with this class is 439. Utterance with confirmation is this. Utterance with get channel package, something like this, 2. So we can see there are some samples, some class data which has very less frequency. Okay, like this one. The get channel package intent has only 2 samples. So we can avoid some of the data which some class data which does not have good frequency. So that removing part is done here. We just see the count of the data. If it is less than 100, we simply avoid the data belong to that class. So this is how we can do some filtering part. It is done to both testing and training data. Not testing, training basically required. And then we again print the testing data. Now we see that all the classes which have less representation, less number of data points, is removed, and we have uh, more balanced data for to train a machine learning model. So these kind of pre-processing people generally do to avoid model train in a strange way. Now the next thing is get the training data and the labels and convert into the list so that we can easily pass to the model. So this will convert everything into the list. And also we need to use label encoder to just kind of train a encoder which will transform the string label to numeric label 0, 1, 2, 3. So he this was the doubt asked by Vivek. So he was wanted to know why we use label encoder. So it's just a single line, and it we just pass the label list into that, and it rest is take care of by this class function. Otherwise you may have to create two dictionaries and do the indexing part by yourself, so it takes time. So that's why label encoder is good. So if you just train here, you will get the statistical information about the data, like how many training data is there. The training data is after filtering 12,234 training samples, and same number of, and total number of classes that we got is 18. In testing data, we have like some class data has been removed, and yeah. Now, if suppose we want to see the representation of each class, we can use this SNS. SNS is here for Seaborn. Yeah, yeah, Seaborn library. So this is used. You can use it to simply plot the histogram just by passing the list of numbers. So training data we pass and see how many data are there for each class. So we have, so after filtering out, we got only 10 classes, and the most data belong to the this third class. Okay, and the third class you can find out just by printing the total number of labels. The third is, yeah, this one, the content only. So the most of the utterance belong to this class. So let's quickly move ahead and see how the classification can be trained by using different approaches. And as we know that our data consists of textual units, sentences. So we have to convert those sentences into numbers, okay, in kind of word embedding. So for that, we just use a spacey model, okay, word embedding model, which will take any piece of text as input and generate the embedding. So we simply wrote this encode sentences function, which will take the list of all the sentences and apply that spacey model. Okay, and this, when you apply the spacey model on a sentence, it returns a vector of certain length. Okay, so we also print out what will be the size of vector length. So it's said 300. Now, so I already found out the embedding of training and testing data, and I printed out the amount of time taken to generating the embedding for those sentences. For entire training data, which is nothing but the 12,194 training samples, with those many sentences, it took around 4 minutes 20 seconds to encode all those sentences. Test data consists of only 3,489 sentences. It took around 1 minute. So when you have encoding of all the sentences, now each sentence is represented by 300 numeric values, which are nothing but the embedding. Now we have both sentences into the number, in the number format, the label also in the number format. Now we can easily give the pair of input and label to the machine learning model, and yeah, train a classifier. So we loaded logistic regression, linear SVC. So this is actually support vector based machine classification, decision tree classifier, random forest. For the naive Bayes implementation, we just call Gaussian naive Bayes. Here the Gaussian, what it does is it uses the Gaussian distribution to estimate those likelihood and prior probabilities. And yeah, so we need to load all of them. Yeah, loaded. And now call the function, call the class of those models. So logistic regression, a class will initialize the model on that. Okay, and passing this parameter 10,000. So 10,000 we set the maximum number of iteration it will take. And linear support vector classification, decision tree classification, all those models we initialize. Now our job would be to pass the training data to these models, to the classification, and to train the classifier, and then later on we can pass the testing data and do the prediction task as well. And because we also need to see the evaluation outcome, the output that we want, like accuracy, the precision and recall and F1 score. I hope these evaluation matrices is known to all. If not, you can ask separately, or we can discuss afterwards. So precision recall are evaluation metric, like how many true positives are returned from the all positive examples. Okay, so based on those true positive, true negative, false positive, false negative, based on that, these eval metrics are estimated and uh, score are calculated, and those score give us idea like how much better a model performs on the given data. Okay, so we also defined a function for model evaluation, which takes x and y, means input and label data, and number of folds, and then do the cross validation. The cross validation is actually nothing but dividing the data into certain parts and train the model on each part, and then aggregate the accuracy score. Okay, that's how, and it will give a more generalized idea how better the model is able to perform. So instead of training a model on the entire data, we just divide the data into certain parts, okay, certain folds, and do the training and evaluation on that, and to find out how much better the model is able to generalize. Okay, so it will take like do the cross validation on all the models that we have initialized, and we'll find out the testing accuracy, the precision, recall, and F1 score for each and every model, and then we'll print and find out like which model is performing better. Okay, so we'll execute this one. Yeah, so this model, this function is loaded. Now what we'll do, to that model evaluation function, we'll pass the training data, okay, training x and training labels, and the number of fold is 5. Okay, and do the training, and it will return uh, the evaluation matrix values of all the models. Okay, for logistic regression, what is the accuracy, what is the precision, what is the recall, and what is the F1 score. Similarly for all the models, and we'll just print them out as an output. So let's quickly run it again. What problem it got? Okay, so maybe uh, some filtering is done, and because of that, data has been removed. Let's do it again. So here data is loaded. Let's load it again, and then this is just printing. Cleaning is done. Removing the part. Yeah, now there the data is consistent. Okay, it's already done. Scoring. Okay, let's do it again. Yeah, so this time the amount of data is consistent, and passed it to the model evaluation. So this model evaluation, as I told you, it the takes the input and label x and y, and train the various models that we want: logistic regression, support vector, machine-based classifier, and DTR, which stands for decision tree classifier, and random forest, Gaussian naive Bayes. And then ultimately we'll just log the note the accuracy, precision, recall, and F1 score for all of them. Okay, so it's still going on. Yeah, it doesn't will not take much time. Just 1-2 minutes to do this cross validation and find out the accuracy. And Meanwhile, just get ready with your doubts if you have any. I will quickly look at them and then we'll move to the assignment that we have for you for today, and for any other discuss any other doubt that you got, we'll take care of that as well. So in order to understand more deeply about those methods, the logistic regression, the SPM, the decision tree, random forest, naive bayes, how they work, we have found out very good tutorials on the YouTube, and we just sorted out the links and provided here for you to go through them when you get time and understand how uh, mathematically they are implemented and devised for this particular task.